Hello everyone. Let us work out this problem using trigonometric ratios. Let me read out the problem to you quickly first. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 to 60 degrees as he walks towards the building. Find the distance he walked towards the building. So let's make a rough figure out of whatever we understood from this problem. So the height of the boy is given. He is standing at some distance from a building. So if this is the boy, his height is said to be 1.5 meters. He's standing at some distance from the building. So let's say this is the distance line, and the building is of course standing on the ground. It's at right angles to the ground, right? Yeah, so let's say that this is the building. Little bit, because it's 30 meters, right? So I have to draw something to scale. So this is a 30-meter tall building, but okay, and the angle of elevation from his eyes to the top of the building. So his eyesight would be somewhere here. Of course, it is some 2 to 3 centimeters below his maximum height, but that is being ignored here. So this is how he would the line of sight would be, meaning the horizontal. This is the horizontal from his eyes, and so the angle is made here. The angle of elevation when he looks up at the building is 30 degrees. Alright, so the length which is opposite to 30 degrees would not be 30 meters. The height of the building is given to be 30 meters, but the length which is opposite to 30 degrees would be 30 minus 1.5 meters, right? We'll have to subtract the height of the boy. So let me rewrite the length as 28.5 meters. 28.5. We have subtracted 1.5 from 30. So this is the opposite side to 30 degrees. So if I name this triangle as A is where the boy is standing, and BC as the length opposite to the height of the building, which opposite to 30 degrees is BC, which is 28.5 meters, right? And now the boy walks towards the building, and now at a different place where he stands, like he is walking towards the building, and suppose he stands here, and according to the problem, the angle of elevation now, when he looks up at the building, the angle of elevation now is 60 degrees, right? The height of the building would be the same here also, 28.5 meters, but the angle has changed because he has moved towards the building. And let me call this point as O, right? Okay, and now this distance is something which is not given to us, and what we have to find is the distance he walked towards the building. That is, we'll have to find this distance. And one look at it would tell you that these two lines are parallel to one another, right? So we can consider that this distance and this distance is the same. Now let's start calculating. Now what do we have? We have a 30-degree angle. If you consider the triangle ABC first, consider triangle ABC first, you have a 30-degree angle. It's a right angle triangle, and we know the opposite side. The side opposite to 30 degrees, it's 28.5 meters, and the adjacent side is the distance from the building. Let me call the whole thing as x2. Let this whole length be equal to x2, right? And so what is the trigonometric ratio which defines the opposite and the adjacent? So for those of you who are not able to recall, we can always have this SOHCAHTOA in mind, which sine is opposite by hypotenuse and cosine is adjacent by hypotenuse, but we are not at all dealing with hypotenuse in this particular problem. What we are dealing with is opposite side and the adjacent side. So I think tangent would be a appropriate trigonometric ratio which we are going to use. So in triangle ABC, tan of 30 degrees, which is opposite by adjacent. The opposite is BC by AC, and we know what is BC, it's 28.5, and we have assumed the length of AC to be x2, right? But what is tan of 30 degrees? Tan of 30 is 1 by root 3. Okay. So all of this is equal to 1 by root 3. So from here we can say what is x2. x2 is equal to 28.5 multiplied by square root of 3. So let's keep this as 1. And now let's look at the other triangle, the triangle which is made, the right angle triangle which is made when the boy walks towards the building. And now the angle is 60 degrees. The angle of elevation is 60 degrees. So now what we need is tan of 60 degrees, right? Tan 60. That would also be BC by, this time it would be OC, right? Because the boy is standing here at O. So the adjacent side would be OC. And this is equal to 28.5 by, let's call this as x1. Let us call OC as x1, right? And tan 60 is root 3. So what is x1 now? X1 can be written as BC into x1 or root 3 into x1. Root 3 multiplied by x1 is equal to 28.5, or x1 is equal to 28.5 by root 3. Let's keep this as our equation 2. So, but what do we have to find? We have to find the distance he walked towards the building, which would be given by x2 minus x1. So let's proceed and find out what is x2 minus x1. x2 minus x1. What is x2? 28.5 into root 3 minus 28.5 by root 3. So let's say that the common denominator can now be made to be root 3. So multiply both numerator and denominator here by square root of 3. And what do we get? This is equal to 28.5 multiplied by 3 minus 28.5 by root 3. So let me factor out 28.5 to 3 minus 1 by root 3, because this is 3 here and this is 1 time 28.5 here. So what do we get? We get 2 multiplied by 28.5 by root 3, which is now 28 into 2 is 56. So 28.5 into 2 would be 57 by root 3. And 57 being a multiple of 3, we can write it as 3 multiplied by 3 ones are 3, carry over 2. So it is 19 by root 3, and dividing both numerator and denominator by square root of 3, we get 19 root 3 meters. This is what? This is x2 minus x1, and this is what we needed in our problem. We needed the distance the boy walked towards the building, x2 minus x1. So the distance the boy walked is 19 root 3 meters. I hope you followed this problem. Thank you.